Okay, so today we are going to talk about functions. Talk about functions today and tomorrow. So today I'm just going to go through the slides, and then in tomorrow's video, I'll go on Replit and do some programming examples. So I'm in D2L on week 3. That you can find these slides, Python functions, and they're not very long. It's only 12 slides, so I don't think that this will be a long video. So a function is where you have a set of instructions and you can give that set of instructions a name. And then anytime you want the computer to go through and do those particular instructions, all you have to do is just call it by name. And that's really convenient. It allows you to do several things. The main one is that it allows you to reuse certain parts of your code over and over again, which makes for much cleaner, more readable code. So it's great programmer practice when you have some set of instructions that you want to happen more than one time. It's a really good idea to go ahead and just write it one single time, give it a name, and then every time you want those instructions to be used, all you have to do is call the name, and the computer will go find where you defined that function and follow the instructions that you gave it. So there are some kind of built-in functions into Python, and we've already used a few of them. So this just kind of gives you an example of what a function is or what that means. So for example, we already saw the command type. We saw that in the very first week, whenever we were first introducing Python, or the first week of reviewing Python, we saw this command type. And whenever you use this command, it has a set of instructions that says, oh, I'm going to look at what is here inside of the parentheses, and I will return whatever data type you pass into me. So 32 is a whole number. It tells me that is an int. Here we see another function that we already have experience with. This is casting. This is saying take whatever is in the parentheses and I am going to force it to be a different data type, the data type of my choosing. So here we're saying take whatever is inside the parentheses and make it a whole number. Cast it as an integer. So you can see, even though this was in quotation marks and we had a string 32, if we cast it as an int, it becomes just plain numbers. So these are functions, these are commands, and when we call them by name, whenever we use them, the computer knows to go find those instructions. And you and I know how those work. They're built in. We've seen them previously. What we're going to look at some more today is the fact that you, as a programmer, can create your own functions. You can define them yourself, which is really neat. And these are just some more examples of some of the functions that are built into the math library. So if you import math, that says go bring in this math library or math package. Kind of just some different terminology that means very similar things. It says go grab these extra commands that are built in. If you just import them, you can use them in your program. So if you want to create a function, we have another reserved word. We have the keyword DEF, and it's going to be short for define. We're saying, I want to define what this function name that I'm giving you next, what this name is going to be able to do. So then anytime I call it by that name, I am defining, these are the instructions that I want you to execute. So our heading is what we call this very first line here. And the heading is going to have our reserved word. followed by what you're going to name it. And then inside the parentheses, so we're always going to have parentheses. Inside the parentheses, you might choose to pass in information to your function. You don't have to. In this example, you can see there's nothing inside the parentheses. So this time we didn't pass anything in, but you can. And those are called parameters. So the function is going to be sort of in its own like place in your program. And sometimes it can work, standalone by itself, but sometimes it's going to need input to know exactly what type of data you want it to perform the instructions on. So if it does need input, we would put it in the parentheses. And then you might notice that we have all of these things indented over. So just like we say, this is part of a conditional, this is part of a loop, we are also going to use indentation to show this is part of a function, okay? A set of instructions that I am defining that I want you to run every time I call the function by name. So let's look at this example. Define, print lyrics. What do I want it to do? I want it to print out Twinkle, Twinkle, Little Star. So then every time somebody calls the function, so here you can see that's what I named it, and this is actually a mistake that that's capitalized. It should look exactly like we have it here. I bet that the slides auto capitalized it just for being, the start of a line or whatever. But it does need to match the way that you have it written. So if we call print lyrics, what is it going to do? It's going to go find print lyrics and then follow whatever instructions are there. So here our instructions are just to print out Twinkle, Twinkle, Little Star. Okay. You can call a function inside of a loop if you want it to happen more than one time. So here in this example, it's going to loop 3 times, right? Whenever I is 0, 1, and 2. So for every iteration of that loop, what is it going to do? Call the print lyrics function. And what that function does, it's going to do the same thing all 3 times. It's just going to print out the words 3 times. So you can kind of see that here in this output. Okay. You can call a function inside of another function. The only thing that you kind of have to have done there is that if you are going to call another function, you just have to make sure that it has already been defined, that you have created it somewhere in your code before you try to use it. Okay. So here we can call print lyrics, and I can say, if I want you to repeat this action, I am going to define putting this inside of a loop. How many times do I want the loop to run? Whatever you pass in as your input parameter. So here I call the function, now I have input. Notice how there's something in the parentheses. Whatever number the user passes in whenever they call the function is going to be the number of times the loop is ran. Okay. So an argument is what you pass in whenever you actually call it. And the parameter are what we have inside the function heading. So in this example, your X is going to be your argument, and the 2 would be what you actually like pass in as the as like in your call statement. And that's just kind of some vocabulary. You want to make sure you know the difference between those 2 vocabulary definitions. So here we have, here is a function. I know it's a function because we use the reserved word define, DEF for define. Function is called print twice, and then you can pass in. S is going to be your input parameter, and whatever gets passed in to this function is what we are going to print out, right? So it's not going to actually print like the letter S. S is a variable, and what is stored inside that variable is going to be whatever gets passed into the function, right? We said right here, that's going to be our input. So whenever you call print twice and you give it some input, what the function is going to do is print that output out 2 times. So if I call print twice and I pass in hello world, what is this function going to do? Print out hello world 2 times, right? Because I had 2 print statements here. So sometimes we want a function to perform some action, and it's going to, do some calculation, count something up, do some sort of math, something where we are asking it to do some function, some calculation, some instructions that is going to result in some type of answer, and we want to know what that answer is. So if a function has results, we're going to call that a fruitful function. Sometimes we want a function to follow our instructions, but it's not going to result in an answer that we need to get back, right? So in this example, if I want it to calculate the cost, I want it to do some math, and I need the answer back, I'm going to use this reserved word, return. I want you, oh, here it's calculating the tax, right? Because we're going to take whatever the price was and multiply it by the tax rate. If I need the answer back, I am going to say return. So this is going to do some sort of math and then give me the result. So if you need the result back from a function, that means that you need to do something with that result. You could either save it somewhere, so you could like store it in a variable. Maybe you want to like print it out so the user can see what the answer was. Maybe the answer to this function is going to be part of some other piece of code. So whether or not a loop is going to keep executing, or whether or not an if statement is going to enter into that particular branch, maybe you ask it to do some little, like piece of math, and that's part of a bigger math statement, right? So for example, if you were going to write a function that would find the average of a set of numbers, maybe you have one function that adds everything up. So you could call that function to get your total, but then you need to take the result of that function and you need to divide it by the number of items to get the average. So that could be an example of calling a function and then taking the result that it gives you back out and then using it in another mathematical expression. So this is going to be a fruitful function because it uses the word return. If I were going to convert feet to inches, well, there are 12 inches in a foot. So if I said, okay, this is 3 feet. How many inches long is it? The way you would calculate that is you would say 3 times 12, right? It's 36 inches. So if I tell you, if my input is the number of feet, the way you would calculate the number of inches would be to take whatever number I gave you and multiply it by 12. And then you want to take that answer, you want to take the result of that, and you want to return it back to wherever this function was called. So we could ask the user, how many feet do you want to convert? I'm going to read in their input and I'm going to store it in a variable. Notice that we did have to cast it as a number so we could do math with it later. And then if I say, okay, well, this is how many feet, call the function to convert it to inches, store the result of that in inches. Now we have the number of feet and the number of inches both, and we could print out that result. This is actually the end of our presentation. This is our last slide. So the final type of function that I want to talk about is called recursion. A recursive function is a function that calls itself. So let's take a look at this. Here we have a function called countdown. And you can notice right here, one of the possible valid things is that it calls countdown, which means go back up here to the beginning and start over, right? So a recursive function is really interesting, and it almost has like a looping behavior in the sense that you can repeat the same few lines of code multiple times when you put it inside of a recursive function. And so because of that, because you can repeat, you kind of have to think, well, okay, in a loop, one of the things we have to be really careful of is to not accidentally cause an infinite loop. So we have to approach our conditional eventually becoming false. In a recursive function, we have something called a base case and then a recursive call. So if you reach the base case, then your function can stop. If you reach the base case, then you no longer enter into you don't call itself again, you can just stop. So it is very common to have an if-else statement to say, if you have reached your ending condition, stop. Otherwise, do something and call yourself again. Go back up and run this function over again. So in this example, if we called countdown with 10, it would say, okay, countdown, n is 10. So is n less than or equal to 0? No, 10 is not less than or equal to 0. So I would come down to the else, I would print out 10, and then I would call countdown again. But notice that I'm approaching the base case, right? If I'm going from 10 down to 0, my number needs to be getting smaller. So this time we call countdown with n minus 1. When I call this function again, I'm going to be passing in a 9. So then we would print out 9, call the function again with an 8, print that out. We would keep going, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Print the 1, call countdown with a 0. This time, after we've already been through it multiple times, now n does equal 0. So we would print blast off and see there is no more call here. I don't go back and start over because there is no recursive call. All I do is just print the word blast off and then I'm done. So that would be the end of the recursive call. So that is it for functions. Functions are very useful. Just kind of remembering what they are. Functions are a set of instructions. So it's a block of code that we can give a name. And then every time we write that name, it calls that function. It'll go do that set of instructions. So we can use it to say, this little piece of code is useful to me and I'm going to need it in my program more than one time, but I only want to have to write it once and then I can call it again and again. You can have functions where you pass in information by putting it inside the parentheses. Those are input parameters. And you can have functions that will return an answer back out to you. And we use that with the reserved word return. So we can make our functions interactive. We can pass information into them. We can get answers back out from them. That is all for today. I just wanted to go through the slides, and then tomorrow we'll get on Replit and we will program some examples of this. And this is our last programming concept. So after we go through these programming examples tomorrow, that will be all of the content for exam 2, and that will be all of the content that we will cover for Python in this class.